Alright, so today's podcast has to do with significant figures, and I will usually just refer to them as sig figs. Again, that stands for significant figures. Sometimes it comes out sig digs for significant digits, but either way I'm talking about the same thing. Significant figures is really the construct for how in science, whenever we do math, so really in chemistry and physics, most numbers we work with are measured numbers. So you've already seen that when we measure a number, we always read between the lines, or if it's more than 20, less than 21, we might say 20.3. Someone else might say 20.4. And in that measurement, that last digit that we record has some approximation or guess to it. So it's not a firm known value, but it's an estimation or a guess, all right? Because we estimate that last number. So significant figures is typically when we take numbers, we're going to add them, subtract them, multiply, divide them, we're going to do something with them. So significant figures are identifying which numbers are significant, and that last number is not going to be because it's an estimation, and then how does that carry over into how we do math. Alright, so significant figures, a couple rules. The first one is non-zero numbers. Okay, so if it's not a zero, non-zero are always significant. I'm just going to put are always significant. Okay, so any number that's non-zero counts. It is a measured value. Alright, and then the next three is really just two rules, but the second one has to do with zeros. If non-zeros are always significant, then really zeros are the only ones that we really care about. So zeros can occur three different places. They can occur at the beginning of a number, they can occur somewhere in the middle of a number, and they can occur at the end of the number. So I'm just going to call the first one leading zeros. So these are zeros at the beginning. So leading zeros never count, or never are significant. An example of this might be 0.0015 grams. Okay, if we read this on a gram, if we had a very little mass of something, we might have 0.0015 grams. Well, those zeros in the front are not part of our measurement. They're simply placeholders so that we can write a number that small. Okay? So again, these zeros, leading zeros, are never significant. They're not part of our measurement. Again, they're just placeholders so we can write a number that's really small. Alright. The next one's I'm going to call sandwich zeros. So these are zeros that happen between two non-zero values. And sandwich zeros are always significant. And something like this might be 205, I don't know, meters. Okay? So 2 is significant, 5 is significant because the number is non-zero. So this zero in the middle is a sandwich zero. It counts as well. The last thing is trailing zeros. Alright? So trailing zeros can happen one of two ways, but we're going to say trailing zeros are significant if they follow a decimal. So we'll do a couple examples of this. So we could have a number like this. We could have 100 meters, or we might have something like 2.01 grams. I'm sorry, 2.00 grams. Okay, so if we have this one, these zeros are not significant because they are at the end. Trailing zeros are significant if they follow decimal. So these zeros are not after a decimal, so they are not significant. These right here, if you put something on the scale and it weighs exactly 2.00 grams, well, both of these zeros are significant because they follow the decimal point. It is the scale says, well, this is definitely 2.0, less than 2.0, more than 1.9, so I'm going to call it 2.00. You might put that same thing back on an hour later and it might read 1.99. So anyways, there's estimation here, but we're sure about this zero. Okay? So again, trailing zeros are significant if they follow a decimal. So what we're going to do in significant figures is, if you take a measurement, we just want to identify how many significant figures are in each of these numbers. Alright? So in this first one, Leading zeros never are significant, so we have a 1 and a 5. So the 1 is significant, the 5 is significant. So this number has two significant figures. This number right here, 205 meters. Well, 2 is significant, 5 is significant. The 0 in the middle is the same as 0, and they are significant. So this number has three significant figures. 100 meters. If that's all we say, if that's all we write, this has one significant figure, because trailing zeros do not count unless they follow a decimal. And then 2.00 has three significant figures. Okay? So again, significant figures follow right into measurements. We say all the numbers that are significant plus 1, which is our estimation. That's the way we read things, and that's the way we also record them. So each of these last values is an estimation of some sort. Okay? And that's it for significant figures.